removes the first element. Okay? So dictionaries are like an element with key and value that you can have, like a hash table, Java, stuff like that. So you define it with these brackets, no? What is it?
Braces, curly braces.
Curly braces. Great. These curly braces, you have the first element is the key, and the second one is the element. So you have the key, 2 points, the element, comma, key, 2 points, element. And you can access that by the key that you given, not the position only like in a list. Okay? So you can remove elements from a dictionary using del. Use it carefully because it will remove it from your Python environment, so if you use del. And you can ask if something is in the dictionary. So now we are going to see if the else and some iterators in Python. So you can have, if an element is in this list, you go to this row, otherwise you go to the other one. Okay, so my list has A, B, C, and D is not inside the list, so I use the second one, X. Okay? If you want to annotate these things and create sort of a switch or something like that, you can use if, if, yeah, down, else, you can annotate that anytime you want. So you can use while. In Python you use tabs. If you go back to the start, you already find if anything goes inside the while, or if in any cases, you always have this tab. If you start doing this is outside the while, okay? Sorry, great point. So I have a list of, and then start removing it from the start. Okay, so pop 0 is remove the first thing you have on the list. So if you want to use a for, I don't know if it's in here. I have to say this Python notebook is from Pablo Navarro. He is a friend and colleague from work that he did that tutorial, introduction to Python. So it's in the beginning, you have the full link. One thing I didn't say, you can use break functions. So you can have a while with a condition. If it's that condition, you check it inside. You can say, I want to break. I only have to see the first 5 elements and then break it. You just use the break and it's going outside the iteration. So you can use a for. The for in Python works with anything that is from iter tools, an iterator, or a collection. It's going to try to take the element. And this element, I have to check if Python 3 stands, but this element color, you can only use it inside the for, outside the for, doesn't work. So you can print each color that is each element of the list. So something more cooler is that you can use a function called zip. This zip is taking 2 lists and make a pair. So he takes the first element of the lista 1 and the first element of lista 2 and gives me back that pair as an element. So I'm doing a zip between these 2 lists, and each element is going to be element 1 and element 2. So this is the way you can iterate several lists in one form. So you're going to have the first element was rojo, and then you have 15, and so on and so on. You can also use enumerate. Enumerate does. You get him a list, and he gets back a position and the element. So if you want to know the enumerate give you 0 for the first element plus the element. The next one is 1 plus the element. That is a nice way you can have an index or stuff like that. So you always need to have the two things that enumerate is unpacking and zip the same. You have to have two variables to receive what zip is doing. You can also iterate from range, and you can ask a list from range. So if you notice, when you ask a list, the brackets appear. Otherwise, it's taking the elements each time you do the iteration. So how we define functions in Python? So you have the def word, and then you have the number of the function you want to define, and then you have the parameters that you want to pass. 2 points, and then your code start always using 1 tab or 4 spaces in Python. So this function returns a string with the name that I have by parameters. So Pablo made the tutorial and put his name. So we can change. So this was other one. So this is for you always going to assume that if no one gives you a parameter in the function, you are going to take that is mundo in that case. So if the parameter you set the name of the parameter equal to a string or number is going to be the default value for that. If you don't give any name, it's going to take that one. But if you do, you can it's going to take the one given by the parameter. If it's not, take the default. So, you can pass several parameters, and you have to leave the last one by the default. You cannot put default values and then variable values, because Python takes it hopes that the last one is the one is not like hard-coded parameter. So with this asterisk up, we are going to give a list, and Python is going to take each element as a part of the parameter. So you don't have to pass each variable to each parameter. It's going to take it in order. So,
¿qué hace el asterisco? ¿Te permite pasar una lista?
Sí. Le avisas que van a venir muchas cosas y que la ordenen en el orden que llegan, que las pongan los parámetros. So other thing is that you are not sure that what you want to pass, like an argument, so you can leave this in runtime. So you can use these asterisk or args, and cargs is for more parameters. So you can say, I want to pass a list, a number, and then a dictionary. So these two is to tell that this is the keywords coming after. So I don't know how many people here is from computer programming. Sort of?
No,
No?
no.
Okay. Okay. So in Python is a multi-paradigm program language. One of these is object oriented, so you can create classes and objects with Python. You can use class and the name of the class you want to build. Usually it's a nice practice to say that it's from object, and you have this function. The double underscore is like magic calls in Python. That works if your class is a collection. You can define functions to say, okay, this is going to be an iteration and this is an element of my collection. So when you use it in a for or something, Python knows that I can treat that as an iterator. And this underscore init is like the constructor of the class. So anything you want to initialize your class when you're creating an object, you have to put it in this init function. So this is how for Python receive itself and 3 parameters. So self name, you can assign the values self, age, the same, and weight. And then you have a method of the class that it calls saludar and takes the information of his attribute name. So here are creating a class student that today you told me how to pronounce it. Inherit, ¿verdad? Inherit. So you can inherit from persona, so you already have your class defined, so you can use functions defined in the class persona and you can use it inside alumno. So you use this setting up first persona, and then you have attributes from the class student and other functions, doesn't matter. The thing is that you can use classes methods defined in classes earlier. So if you see, we are using this method that is defined in person and not in student. So that's the part. And here we instantiate one object from the class alumno with this name and lectures. So a few differences. In Python 3 you have to use parentheses in print functions. So if I use Python 2 to run this, it's going to have any problem. But if you try to run it in Python 3, it crashes because now everything receives as a function. This is not important. So the thing of before in Python 2, you have to port the full division because it was like integer division, but now it's fixed. I think we can move to Python. Somebody has any questions from the programming language? So now we are going to see NumPy. It's a library for algebraic and matrix manipulation in Python. It's implemented in C downstairs, so you can run like really fast code writing in Python but executing in C. So you can import this way in Python. You use import NumPy, and this as is like an alias. If you don't want to call all the full name of the module, you can use some sort of short name. So in NumPy, you can use the constructor NumPy array, and you can send lists. And you can also say the type of the data that you want to use. Different from Python list, you need that is one type for all the array. You cannot have different types inside the same array. So this is because it's running CD in the low level, so you cannot have. So this is, you can ask the shape, and you can see how is the array created. So this is range from 0 to 63, and the type is int32. You can reshape. If you want a matrix 8 times 8, you can have this time. You have to check that you have to have the correct dimensions. You get NumPy never is going to do a reshape of an array if he lost some element in the running. So if I put here B, it's going to say he cannot reshape because he needs to preserve all the elements of the array. So that's a nice feature. So you can ask the type with the dtype attribute. You can use this type of reshape. I create this here. No, this one.
Celia,
So, sí.
perdón. Para ejecutar es control enter.
Control enter.
Nos da error acá, ¿puede ser que se cambió?
A ver.
Que nos ponemos a ejecutar.
Porque ahí no.
¿Dónde hay que poner?
Al principio. Ahí va, control enter. Porque este es el que importa el módulo. Después de que está el módulo importado, lo puedes usar. Lo vas acá, control enter, y ahí ya.
Está bien, y posicionado directamente al principio. Acá
Sí,
adelante.
sí, siempre porque ves que acá está tratando de usar NumPy arrays, y si no tiene el módulo, no lo desconoce. So other nice thing is you can use -1 if you are not sure of the other dimension. You just only make sure that you have this amount of elements in Y. For example, you can set -1, and NumPy is going to try the best to get the new array with that shape. So what he did was create an array with 4 rows and 16 columns. 4 rows with 16 elements. So inside NumPy you also have a random module. You can ask for the classical distribution to get values, or you can use random, like this one. And you can pass the dimensions that you want. This is a matrix 5 times 5 with random values inside. Also, you create a linear space. You can say, I want 9 values between 0 and 2, and creates this type of array. So you can ask the classic functions. You have mean, standard deviation, accumulative sum, and a bunch of others. You can apply all these to an array. You can also use Python operators. Be aware that if you use the operation with NumPy, np dot, and the operation you want, that is going to be implemented in efficiency. If you use operator in Python, you are going to use operation running in Python. So a bunch of data and you need it quickly, use it Python operation, no Python operation. So you can do operations, adding, removing elements. This is from Jupyter Notebooks and ePython Notebooks. If you use the underscore, it's going to take the variable output from the previous cell execution. Okay? So this one is going to show me the output of this operation. Also, you can use a number. So I said I want 15. It's going to give you the same. You can say the number of the line and it's going to take the output of that cell. Es interactivo, es solo para que si dejas el underscore solo, te saca lo que había almacenado en la celda anterior. O sea, la salida de A menos B. Si le pones el número, te va a la línea que tenías ejecutada y te lo puedes guardar en una variable. Esto solo sirve si estás ejecutando en ese momento. Apagás el notebook y eso deja de funcionar. So we can do some reshaping. Now a little bit of a slicer. So this is our array. The same way of a Python list, you can take all the elements, or you can take, this is like, it's going to say the first row, the second one. Second row, all the columns. That's right. This.
Porque no hay tres ya.
Claro, porque no hay tres. So this is taking, doesn't want the first one, that is the 0 position, I want the second one. And to 2 there is no 2, so it's 1, 0, 1. And you get these. So you have all the columns, but second row. So the first part is the rows, and the second one is the columns in the NumPy array. So this one is, I want all the rows, but only the first column. Please remember that the border doesn't affect, it's -1 always. So something that we are going to use when we train our networks is stacking a bunch of arrays, because I will have like a bunch of images. Each image is going to be a NumPy array, and I want to put like several training images, so I want to have a stack of images with NumPy. So a nice thing is bstack function for NumPy, so you can stack all the arrays that you want. So check out that you have to have the same size of arrays. So if you do this here, for example, it's going to fail because it can have the same array. But if you do an horizontal stack, so you're putting this one and this one together, it's going to work because it doesn't break the shape. He's starting like one NumPy array horizontal. The other one is stacking, so with the stacking he needs the same amount of volumes. So you can have a linear algebra module inside NumPy, so you have all the classic functions for working with matrices. You can have the transpose, you can have the inverse, you have the identity matrix, you also can have all ones. You can do a dot product. These two underscores is that I'm using. The first one is the past array, so in the past line, in the 31 here. You can also have trace of that one. So, and if you start looking, if you do this, if you say the name of the module dot tab, you're going to have all the functions that you have inside that module.
Dot tab.
El nombre np.tab.
Tab.
Si haces tab, te empieza a listar todo lo que tiene. if you put
Perdón,
sí.
¿el NP es porque está haciendo siempre NumPy o...?
Sí,
O sea, porque
es
estaba
el área
utilizando
que
la
usé,
librería.
exactamente. Sí. Acá tienes dos cosas, vos puedes tener tu objeto array y a eso le puedes poner punto y tener un montón de operaciones, o usás desde el módulo las funciones que tiene el módulo, que son dos formas distintas. If you use interrogation sign by the end of a module, a function, or anything, you're going to have the documentation open up. So usually you have a bunch of examples, or if some application you have the paper pointed of that implementation and stuff like that. So this sign and the completing tab only works in ePython and Jupyter notebooks. When you're going to code your big modules in Python, you don't have to expect to work. This is only the interactive part. So this is like a small introduction. NumPy is a huge library. You can have a whole tutorial only for NumPy. We are just picking up the few things we need to build our models. So anyone has a question? Someone has this running
Sorry?
in your machines? You have these notebooks? Okay, you can try doing some matrix operation, like a dot product or something, just to check.
Sí, no,
Sí.
por eso te pregunto que dice mejor.
Pero lo que pasa es que acá le puso imagen JPG y acá dice slide y yo borro esto.
Sí, pero ¿de dónde lo leo? No, porque te vas a poner...
1, 3, 4, 5, 6.
Que decía acá.
Ay, capaz que no capaz que sí, no lo tenemos.
Pero lo haber hecho recién. Y acá sí, miércoles le decía, si lo guardé en el buffer. Acá, ahí lo tengo. Eso decía.
¿Qué decía?
La imagen. Y modificar cosas y ejecutarlas supuestamente. Pero lo que supuestamente la imagen no sé de dónde la sacó, cómo se llama. Si yo acá le pongo el nombre, la tengo en el disco, lo debería ejecutar.
I find your laptop. Capaz que lo puso recién.
Pero debería estar acá, a ver cómo se llama, Monty. Acá.
No sé,
Si lo ordeno por nombre, Monty. El tema es, pero debería estar probablemente en alguna de estas. ¿Monty?
Ah, no, pero...
Otra vez la misma historia, ¿dónde lo estoy compartiendo?
Claudio, ¿tiene que salir su imagen igual, así de una?
Sí.
¿O cómo hicieron para cambiarla? Porque no sé, no sale otra imagen.
A ver, no sé, fíjate si no las puedo, no sé si no las equivoco.
A ver, espera.
La celda de la imagen.
No, es que nosotros nos dice, por ejemplo, imágenes NumPy-slides. O sea, en vez de decir NumPy solo, por NumPy no vemos nada.
Debe ser otra versión del
archivo,
claro.
Acá,
Ahora que cambió,
acá debería estar.
No, que
Sí,
Julia es un
está.
poquito
Ah,
así.
NumPy. Está en la carpeta de NumPy. Lo tendría que hacer.
Ah, entonces no sé por qué no lo hace.
Si yo le saco NumPy, si yo le saco slides, esto, como hice
¿Para qué
hoy,
te digo que
probablemente haya que ejecutar algo antes, como me pasó hoy.
A ver. Bueno, siempre tendría que hacer.
La tendría que ir abajo, como me hizo bajar. no responde, que te va a dar tiempo. ¿Qué quieres saber de eso? A ver ahí, ¿qué hizo?
No lo sabe.
No me la ejecute, no me lo tampoco. No, más abajo. Pero la lista esta era la lista. Esta ahí. Claro, estábamos parados en otra línea. Esta decía lo que debería decir, lo que tenía que decir, esto como estaba. Igualmente no sé si yo eso cambio porque no me hace nada, no sé, debería ser.
Si estamos haciendo cambios,
Exactamente. Esta es la imagen. No más nada. Sí.
cambiando de arriba, a ver. ¿Qué hace Trace?
Trace hace algo con respecto a esto, porque está con el underscore.
3, 4. 1, 2, 3, 4. No sé si está.
Obviamente está diciendo, pero no necesariamente, o sea, vos estás diciendo la cantidad de filas de columnas o algo así, 3, 4.0.
O sea, si vos sumando